Hello everyone, I am Vipin Kumar and I welcome you all to iitiansgateclasses again with you. And in this session, what we are going to do, we're going to focus on the heat and mass transfer questions in the GATE 2023 Mechanical Engineering paper. Okay, I hope you all had good, the paper went well for all of you, GATE 2023, and I wish you all the luck for joining good IITs as well. Right. So also the response sheet is out. You can see if you have marked the questions correctly or not. And in this session, we are going to focus on heat and mass transfer questions again. Okay. So you can cross check your questions as well from this session. Now let us start this session. So what are we going to focus on? We are going to focus on heat and mass transfer, and it came of 6 marks. Again, it is a good weightage, right? It's a good weightage in the GATE exam for heat and mass transfer. Okay, let us start. Let us start the question number 1 that came from heat and mass transfer. Okay, the question is saying consider a laterally insulated rod of length L. So we have a rod whose length is L and it has a constant thermal conductivity. Assuming one dimension heat conduction in the rod, okay, only one dimension heat conduction we are going to consider. Which of the following steady state temperature profile or profiles, okay, so that means more than one option can be correct, can occur without internal heat generation, Now let us try to understand it, what it is saying. So what do we have? First of all, we have a rod. So let us say that we have this rod, okay, and this is your direction X, this is your direction Y, and you also have a direction Z inside in the depth, okay, Z. And thermal conductivity they are saying is constant, okay. Now let us try to see what kind of temperature profile it can form. So first of all, we have to start with general heat conduction equation, right? And we will apply the assumptions there, okay. Now what are the assumptions? So first assumption, constant thermal conductivity and one dimensional heat conduction, okay. So first assumption is thermal conductivity is equals to constant. Second assumption is one dimensional heat conduction. That means Q dot Y is equals to 0, Q dot Z is equals to 0, okay, and it is insulated, okay. So it is insulated, laterally insulated, okay. So no heat conduction in Z direction, only in X direction heat transfer is taking place, okay. What else? And no internal heat generation, okay. And steady state. So third assumption is steady state, and fourth assumption is Q dot generation is equals to 0. Now I am hoping that you all know the generalized heat conduction equation, and if you apply all the assumptions there for one dimensional steady state and Q dot generation is equals to 0, then what will be your temperature equation? Temperature variation equation, it will be d square T by dx square is equals to 0. And as I have told you in all my sessions, how are we going to solve it? We are going to integrate it twice so that we will see how the temperature is changing in X direction. So X direction, let us say X is equals to 0 here, X is equals to L here. The entire length is L. Okay, so we are going to see how the temperature is varying in x direction. How we are going to see that? We are going to integrate it twice. So first of all, we are going to integrate. We will get first integration dt by dx is equals to c1, and then we are going to integrate one more time. So we will get t is equals to c1x plus c2. Now this equation is a temperature variation in x direction. It is how the temperature is varying, temperature variation in x direction. And by seeing this equation, I can say that temperature is a linear function, or it is varying linearly, linear function of x. So it is varying linearly. So if I see the options, options C and D, you can anyway neglect. It is temperature, it is the linear variation. Temperature is varying linearly. Now let us say that, one second. Let us say that at x is equals to 0, temperature is equals to T1, and at x is equals to L, temperature is equals to T2. Okay. Now there are two variations that can happen. So if the case one, if temperature 1 is less than T2, then this kind of a temperature profile is possible, and heat transfer of course takes place from high to low temperature. So this is how heat transfer is taking place. Okay. What about if T1 is greater than T2? Okay, this is T1, this is T2, then this kind of temperature profile is possible, and this is the direction of heat transfer. Okay, so both the options A and B, it is a multiple choice question. Okay, and that's why they are saying which of the temperature profile or profiles can occur without internal heat generation. So A and B both are the correct options. So correct options are, correct answer is A and B. Both are the correct options. Okay, I hope it is clear. Let's move on. Next question from heat exchanger. Again, 1 mark question. Very easy question. Okay. Now consider a counter flow. As soon as you know it is a counter flow heat exchanger, what are you going to do? You are going to draw the temperature profile. So this is the length of my heat exchanger. This is, let us say, fluid 1, and this is fluid 2, however you want to say it. So one fluid is flowing in this direction, one fluid is flowing in this direction. Okay, with the inlet temperatures of two fluids 1 and 2 being T1 in is equals to 300 and T2 in is equals to 350. Now most of the people, I don't know why they do it, they just start writing T1 in here, but it's not correct. Why? Because T2 in fluid 2 is entering at a higher temperature. So what you are going to do, you are going to write T2 is entering at 350 Kelvin. Okay, and T1 is entering. So T1 here, one second. T1 here, T1 in is equals to 300 Kelvin. Okay, so now this is my fluid 2, this is my fluid 2, this one is my fluid 2, and this one is my fluid 1. Okay, now let's read the question further. The heat capacity rates of the two fluids C1 and C2 is this. So they are saying C1 is equals to 1000 watt per Kelvin. Okay, and C2 is equals to 400 watt per Kelvin. Now what is this? This is mass flow rate into Cp. That's why it is watt per Kelvin. Okay, now the effectiveness of the heat exchanger is 0.5. The actual heat transfer rate we have to find out. Very easy question if you know the concepts, if you know the formula. Effectiveness is given as 0.5. But what is effectiveness? It is Q dot actual by Q dot maximum. And we have to find this. Okay. So Q dot actual will be equal to 0.5 into Q dot maximum. Now, how do you find out Q dot maximum? It is C minimum and temperature difference will be maximum, right? So what is the C minimum? Fluid 2 has the C. So 400 into what is the maximum temperature? T. I don't think I need to write all this because you are all well prepared and I don't think I need to write the terminology. But anyway, chalo. Now, this is 0.5 into 400 into 350 minus 300. So it is again 50. And when you solve it, so this is around 20,000, right? This is 20,000 and this is 10,000 watts. They're asking in kilowatts. So Q dot actual is equals to 10 kilowatt. This is my answer to this 1 mark question. 1 mark question. Okay. I hope it is very clear. There's nothing in this. Very easy question. It should not take less than 20 seconds, more than 20 seconds to solve this question. Very easy question. Just draw the diagram, write the formula, and solve it. These steps is not required while you are, solving in the GATE exam. Chalo. Let us move on to the next question. Third question. Question number 43. Now, this is a 2 mark question. 2 marks. Okay. A cylinder rod of length h and a diameter d is placed inside a cubic enclosure of side length L. Okay. So we have a cylinder whose length is h, diameter is d, and a cube we have. So cylinder is inside the cube. S denotes the inner surface of the cube. The view factor SS is. View factor of SS is. So let us try to draw it again here. Look, you have a cube. So this is my cube. Okay. And we have a cylinder inside it. We have a cylinder inside it. Okay. With dia D. And this is my length H. And what about the cube? It has length L. Okay. This is also L. This is also L. And this is also L. Okay. Now the view factor SS, it is saying this surface, this cube surface inside surface is S. So I need to find out FSS. So sometimes it can be confusing to people. Okay. So what we are going to write, let us assume that this is surface 2, this cube is surface 2 inside, and this cylinder is surface 1. Okay. Now if they are asking FSS, that means I need to find out F2, right? Because I am assuming that cube is 2, is second surface inside cube surface. Okay. Now tell me one thing. So many times I have done this. Okay. Same steps. Tell me what is F11. F11. It will be 0, of course. Whatever radiations are emitted from surface 1 is not going to fall on surface 1. Okay. And then if I apply summation rule, if I apply, I don't need to write all this, but anyway, just for you. F11 plus F12 will be equal to 1. So from here I can write F12 is equals to 1. Okay. Good. How much is falling? How much what is the amount of radiation that are leaving surface 1 and falling surface 2? All the radiations, so it is F12 is equals to 1. Now, I will apply reciprocity rule. Reciprocity rule. What is reciprocity rule? A1, F12 is equals to A2 F21. Okay, so from here I can write F21 is equals to A1 by A2 and F12 is equals to 1. So I don't have to write it. Okay, now what is A1? Area of the cylinder. Area of the cylinder. What is the area? It is pi dh. Okay, outside, and the cylinder area, tube area is pi d square by 2. Okay, and then what is the area of the cube? What is the area of the cube? It is 6L square. 6L square. But are they asking F21? No, they are asking F22. F22. So sometimes people are in such a hurry that they will directly mark option number 3, which is not correct. Okay. Now again, I have to apply summation rule. Summation rule I have to apply. And what will I do? F21 plus F22 is equals to 1. And F22 they are asking in question 1 minus F21, and therefore I can write F22 or FSS is equals to 1 minus pi dh plus pi d square by 2 by 6L square, and this is the correct. So option number D is correct. D is correct. Okay, I hope it is very clear. There should not be any doubt in this. Okay, now let us move on to the fourth question and the last question for that came from heat and mass transfer. Okay, again 2-mark question. So there were 2 questions of 1 mark each, and there were 2 questions of 2 marks each. Okay, so 6 marks total came from heat and mass transfer. Now, what is it saying? A very large metal plate of thickness D. Okay, this is the metallic plate. Okay, it's like this. It's like this, a metallic plate. 1 second. This plate is like this. Okay, and its thickness is D. This thickness is D. And when they are saying very large metal plate, if they are saying very large metal plate, that means D is thickness is very, very small than the length. This is length. This is my length. Okay. And thermal conductivity is what? K of this plate is cooled by a stream of air. Some air is flowing. Some air is flowing like this. Okay. And T infinite is equals to 300 Kelvin. With a heat transfer coefficient. Heat transfer coefficient is also there because convection is happening. Center line temperature is Tp. In which of the following cases can the lumped parameter model can be used to study the heat transfer in metal plate? Heat transfer in metal plate. I need to find out which option is correct. Which option? And again, see, it is case or cases, so there can be 2 options that could be correct. Okay, so more than 1 option can be correct. Okay, so let us start. Let us start this now. What do we know? If you all remember, for lumped heat capacity to be valid, if I say that this heat transfer can be comes under lumped heat capacity analysis, then what is the criteria? What is the criteria? Biot number should be less than 0.1. Internal conductive resistance is much smaller than external conductive resistance. No, but what is Biot number? Biot number is HLC by K of solid, thermal conductivity of the plate. Okay. Now I need to check all the options. Look, a combination of h, k, and thickness is given. So I have to see which option is correct. Which option is correct. Now, in order to calculate LC, what can I do? LC is equals to volume upon surface area. Now, what is the volume of this plate? What is the volume of this sheet? Length into thickness. And what is surface area? L into L, so L square plus L square. Why? What is the surface area? Surface area is, sorry, one second. Surface area is the upper surface area and the lower surface area. So here also the air is flowing. Okay. So upper and lower surface area I have to take. Okay. So L square. So if I do this, I'll get D by 2. LC is equals to D by 2. Okay. Now let us see all the options. So option A, what does option A is telling me? H is equals to 10 watt per meter square Kelvin. K is equals to 100 watt and diameter is equals to 1 millimeter. 1 millimeter. So I have to convert this into meter because everything else is in meter. Okay. So I can write Biot number is equals to H. So what is H? H is 10 watt per meter square Kelvin. And what is LC? LC is D by 2. So D is 1 millimeter. I have to convert that into meter. And it is D by 2. So I have 2 here. And then K is what? K is 100. So if you solve this, you will get 0.5 into 10 to the power minus 4. So is it less than 0.1? Of course it is less than 0.1. So this answer is, these parameters can be considered as lumped heat capacity under lumped heat capacity analysis. Okay. Let us see option B. What is option B is saying? H is equals to 100, K is equals to 100, diameter is equals to, thickness is equals to 1 meter, 1 meter. Okay. So I can write Biot number is equals to H is also 100, thickness is 1, and then I have to divide it by, because I have to take LC, right? And this is also 100, K is also 100. So you will get 0.5. Now is it less than 0.1? No. So it cannot be considered as lumped heat capacity analysis in valid condition. Okay. Let us see option C. H100, K1000, and again it is in millimeter, Okay. So Biot number in this case, H is 100, D is 1 millimeter, so 1 into 10 to the power minus 3 divided by 2, LC I have to take, okay? And K is 1000. So it is like this only, okay? It is like this only. Okay, so it will be again 0.5 into 10 to the power minus 4. Okay, so again this is valid. These conditions can be considered under lumped heat capacity analysis. And the last option D is telling me H1000, K1, and D also 1 meter. So I don't have to convert this again. Okay. So D option I can take Biot number is equals to 1000 is 1 meter. So 1 by 2 and K is 1. So it is 500, which is very, very high. It will be foolish to consider it as lumped heat capacity. So it is again invalid. So which options are correct? A and C both are correct. A and C both are correct. Okay. So what are the correct options? A and C gives you the correct answer. So these conditions can be considered under lumped parameter model or lumped heat capacity analysis. Okay. So correct answer is A and C. Okay. So these were the questions that came from heat and mass transfer. Okay, these are the questions that came from heat and mass transfer. Total 6 marks, and that was asked from heat and mass transfer. Very easy questions. sometimes they do not ask these easy questions. Okay, so if you have the basics, it's very good. Okay, so it's very easy to score these marks, and I hope that you have attempted all of them. Okay, chalo. So I'm going to see very soon for regular classes. And if you are also preparing for GATE 2024, it is the right time to start your preparation, right time to make a strategy, start following that strategy. And it's also a good idea to take guidance from people who have passed GATE. Okay, so you can ask anyone. You can also ask me. You can connect with me through this channel. Okay, so soon we will meet for the regular classes. Thank you. Thank you very much. Okay, sir. हाँ जी, yes. Okay.